I remember the first time I first laid my eyes on a pendulum bulb. I was in my senior 4, a young blood, in a physics practical lesson. I tell you one thing, it was mind-blowing. Naturally, we human beings have a photographic memory. It is very hard for someone to forget something they've seen before, especially when they've seen it for the first time. As generations come and go, technology advances. Students, learners across the world crave for more information, but in a more interesting way. This is why I'm here. Welcome to Digital Science for You.
All right, welcome back. I'm Nicholas Masajage, your mathematics teacher. Okay? Today we are looking at a new word which most of you have not heard about. If you're a teacher at home, if you're a student at home, watch this. This word is mensuration. Mensuration. Very uncommon word, rarely used, which is another word. In mathematics, this word means measurement. We measure the parameters about any object we have. Volume, length, area, surface area, all those fall under mensuration. Today, particularly, we're going to look at volume only, capacity of volume. How much is held by something? How much volume is in there? How many properties, how many particles are packed inside a single object? That's the volume. So, for you to be able to make something that can actually hold a certain amount, you must know the volume you need to put there. Yes? For you to make a cup that can hold 1 liter, you must be able to make a volume. For you to be able to get a bottle of soda and then you put there 300 mils, you must know the volume that the bottle can hold. Yes? That's what we're looking at today. Now, for teachers at home, digital science has come as a solution for you. If you're making a lesson plan, your objectives are right there. The objectives are stated clearly. So under digital science, today we're going to senior 3 and we're looking at mathematics still, senior 3 for all, and then we're going to look at volumes of solids. The objectives under this topic must know how to set the units of volume, convert units of volume from one form to another, calculate the volumes of cubes, cuboids, and cylinders using unit cubes, state units of capacity, convert units of capacity from one form to another, relate volume to capacity, solve simple problems in volume and capacity. Capacity is what you have normally in liters. Now volume is what is mathematical. Yes? Our mathematical bit is volume. In senior 2, we look at only shapes, the shapes, the way they are made, geometry, nets, and solids. Now in senior 3, we go ahead and find out how much volume a particular shape can hold. So a prism, any shape with a regular cross section, with a similar cross section is a prism. Any shape. If you have a cross section which is uniform, that's a prism. Shape 1 here, if I tap the first shape, you see as it rolls, it has the same cross section. Yes? This is digital science. Next shape, that's a prism. This is also, you can see it is coming from a single cross section. It's also a prism. Next shape is also a prism. Single cross section. The cross section must be the same all the way through. Let's consider first a cuboid and then what shape is in a cuboid. If you look at a cuboid, the shape that's in there, I told you last time under senior 2, the difference between a cube and a cuboid is that a cube is a square all the way through. Every cross section of a cube is a square, while a cuboid is rectangular almost all through. So we are forming a rectangle out of a cuboid. See that rectangle, it comes out, that is the cross section. If I pause there, you're going to say that is the cross section. Everyone knows the area of a rectangle. You can ask anyone around you, they'll tell you the area of a rectangle. Length times width. Everyone knows that, very simple. Now, if you get those rectangles, if I play, and then you add them up, add all the rectangles together, they form a height. They raise to a given height. So we get these rectangles and keep on adding them up. We add them, add. We keep on adding the rectangles. As we add them up, they keep on increasing in height. Yes? Developing for us a height. So we get the area of a single rectangle joined together to form our volume of the cuboid. So the number of slices times the area of a single rectangle gives us the volume of the cuboid. But we already know LB is what? Is the base cross-sectional area. So this is the cross-sectional area, LB, times the height. So generally, the volume of a prism is the area of the cross-section of the prism times the height or the length. Get the cross-section of the prism times the height, you have the volume of a prism, any prism. Let's look at another prism. If I'm to continue here, sliding here, if I slide here down, let's look at this one here. I move it back a bit so you can see how it comes about. Yes, back there. Do you see? Same thing. If you have a triangular prism, yes, same thing. You see various cross sections form for us that prism. But the cross-sectional, one of them is only a half length, half base times height, or a half LB, and then times the height. So the area of the cross-section, the triangular cross-section for this one, times the height, gives us the volume of this prism. Let's go to the next one. Let's roll for another one. Let's see if there's another one. Cylinder. Good. The cylinder. The commonest shape we have is a cylinder. Commonest solid we have is a cylinder. If you look at the volume of a cylinder, also it is formed of various shapes. What shape would it be? A circle. Correct. It is a circle. Yes. So you get the circles, and then volume of the circle. You get one circle, and then you keep on piling up the circles. One shape forms a circle, but then when you get all of them together, you're going to have the circles increasing. That's how they increase to form for us our cylinder. So the area of a circle is pi r squared times the height. You get the volume of a cylinder. The area of the cross section times the height. Please remember that. Area of cross section times height. Yes? Very good. Let's continue the next one. If I continue to 3, we're going to find out the volume of some examples here. Yes. In real life, examples. A box of matches. Yes? Very simple. It's cubical and formed of, we say, the rectangle. So the cross section is a rectangle. So we get out these ones here, simply multiply the area of a single rectangle, in this case 6.4 times 4.5 times the height, which is 2.5, to get us the volume of the matchbox. Yes? If I'm to go the next one, all right, yummy, right? Yes. Everyone likes chocolate, right? Do you know how much volume of chocolate is in the chocolate you're eating? Let's see. A chocolate bar is in the form of a triangular prism. This is an Adelaide almond, but you have various kinds of chocolate. Cadbury, some are testing Cadbury, yes. This is a chocolate. So if you are to get also the cross section, which is a triangle, the cross section is a triangle. So a half times base times height. That's our area of a triangle, which is our cross section. Therefore, it's our area of the cross section. So a half times base times height times the length of the entire cross sections joined together to form for us our chocolate. Yes? So the volume of the bar is base area still times length. 5.4 times the length, which is 10, to give us 4 centimeters squared. Remember, its area, units for area are square centimeters or square units. Centimeters squared, meters squared, those are units for area. Now, when you're getting the volume, we are multiplying by another length. So square meters times meters gives you cubic meters. Meters cubed. Yes? That's how we get the units for volume. You simply put a power 3. So it is power 3. Meters squared times meters gives us meters power 3, which is the unit for volume. Yes? Or centimeters cubed. Now let's continue with this one. Let's see this one here. This is, you have canals which flow. Canals are simply which are used to flow water. Some of you have corrals at home. There's a trough, like canal, where you feed your cows from. Something similar to this, where you see the water. You see that water flowing? It's flowing out of a canal. Yes? So this shape here forms for us a trough. And it's also a prism. So the cross section is actually, you can see the cross section, a trapezium coming out as our cross section. This trapezium, the area is simply a half times the height, yes, times a plus b. Here we are, so 5 meters plus 12 meters. This is times the height, which is 4. That gives us our area of the trapezium, 34 meters squared. Now to get the volume of water flowing through that canal, we'll go ahead and multiply by the length of the canal, which is 15 meters. So multiply by 15 meters there. That 50 meters, we bring it here and we multiply, and then we end up with 510 meters cubed. So we are flowing out 510 meters cubed out of any canal. They're building a line to take oil out of Uganda, to transfer the oil. That line, they must know how much volume is going to flow through those pipelines at any one moment. For that to work, you must be able to have some mathematics. Those who want to take on oil jobs, yes, I'm getting you, right? On that note, we're going to go for a short break at exactly the canal where we're talking about the oil that's going to be flowing, and then we'll come back and continue with our volume.
It's time for a small breather. It's about that time you get on your phones, give us a feedback, your reaction on our Facebook page and Twitter handle CSTSUG. And for all of you who managed to get in touch with us, thank you so much. It's been a great pleasure. And for all of you schools that haven't got in touch with us, you can make your way down to our main offices in Lugogo, that is Uma Show Grounds, and you can have more of these lessons. And also continue following us on our Facebook page, that is CSTSUG. We'll take a small break. When we get back, we'll be coming through with more of those lessons.